this opportunity. In fact, I should thank Ms. Dr. Raman. This is a long term our all Lidar community used to discuss it. Why don't we have our own society and have some kind of forums? And it has taken the shape through Raman. I should thank and congratulate. Thank you very much. And coming to this domain is, though I'm from the Lidar for the atmospheric science applications, down the line after joining in defense, understood that it has the multiple utility in for the defense applications. So we used to interact with the civilian sectors and defense sectors and get the requirement from them and develop the system. Like Professor Jaraman has taught everything from the fundamental to end and shown the results. Now, what the similar one, now we have one step gone ahead. We are trying to make it commercializing the products. Now our products, like whatever I'm going to speak is, we develop first prototype, evaluate it, validate with the commercial equipments, and give it to scientific people and get the results what is required for the atmospheric scientists. And thereafter, there is defense forces for them. There is a requirement for them also. That also we have validated, then move on to the next levels. So that's how we have evolved last 15 years. Now I will show you one by one. Yeah. So first I will describe why do we need Lidar system, not for atmospheric science. And ladies saw a start. Let me put it in different aspects, okay? And then we have developed some 3-4 variants. 3-4 variants, like starting from Lidar Systems, that is cloud lidar, aerosol, and test and evaluations. When I say cloud lidar, we have the different variants within that one. Millijoule energy, microjoule energy, scanning lidars, all those things. So something I will touch upon all the technological capabilities. The main aim is Atmanirbhar and make in India. What the science we learned, what we want to give it to the society. That is the prime motive. And comes next, development of differential absorption lidars. Anyway, Dr. Raghunath will be talking about for atmospheric applications. Here, the same technology, same concept, how I can use it for protecting our forces, like Army or Indian Navy, how the same technology is seen, but how I am building the system, how I'm protecting it, that I will be talking about. Within that also, I have the 2 variants. One is vehicle mounted lidar systems, which is built within India. I'll show you their results, which is operational in 9 to 12 microns. Another system is OPO laser-based systems, which operates in 3 to 3.5 microns. Thereafter, all are parallel activities, not the one after one. And we have also developed UV LIF lidars, fluorescence lidar. And this is one of the very important technology which is very much useful for the defense forces for protecting against the biological aerosols. Anyways, some brief introduction also I will give you. So in cracks, we work right from 0.2 micron to 12 microns. Whatever the wavelength you talk about, finally I will tell you one more wavelength which we are going to use it for another applications. So here the system developed, realized, tested and evaluated, and going for manufacturing or fabrications. So let's see one by one. The current status and way forward, that's where the currently we are, and we'll talk about it. And this is just in a pinpoint I'm telling you. When we interacted with Indian Air Force and Indian Meteorological Department, there is an immediate requirement that the safe landing and takeoff of aircraft, especially during monsoons. And another important point is LiDAR is one of the potential safety instrument as per WHO. In India, only 2-3 airports are having it. Remember, LiDAR is so much required for these services, which we do not have it. And we come across in discussion with IMD and our Indian Air Forces, and they have placed a requirement as we want to have the LiDAR systems, which is operational by 24/7 and should be able to give me the cloud-based sites. Why cloud-based? It's very important is just think that you are trying to land from the top, from the high altitude. If you are inside the clouds, the pilot cannot see what is the base of the cloud from the ground. There should be somebody, some instrument has to tell that, because that's the decision altitude, we call it as 500 meters. If it is above, then aircraft will be landing. If not, get into the accident. There are 2 incidents that happen in India. Just to dig out in the newspapers, you will come to know, or especially the failure of intimating cloud-based rides. Then it will serve the purpose. You should have the conical scanning and aerial sector scanning. This I will come little later. Coming to another important applications. Let us assume or consider there is accidental release of industrial exhaust, highly toxic chemicals. One. Second thing is, if intentionally somebody releases highly toxic chemicals to the places where our troops are there, our civilian people, our populations are there. In that situations, you should have some instrument should capable of detecting from far off distances. That is not point sensors. Lidar is one of the potential application for this one. And the example which I am trying to done. No issues. I'll wait. Is it okay, sir? It's okay.
Yes.
Shall I go ahead? Okay. Now just you take figure 1 and figure 2. Figure 2 is the very latest one, 2013. There is one more 2017. There is some use of chemical warfare agent against the public. One happened in Syria. Okay. This is one of the agents. If you are exposed for only 2 ppm for a couple of minutes, you are gone. And these kind of agents can be released through UAVs or artillery shells in the atmosphere. Once it is released, it will form like cloud and slowly disperses. And it is like aerosol for you, or it is like a chemical pollutants, and you have to detect it from far off distances. So hence LIDAR. Now let me move on to next one. Another essential. This is the essential requirement of the society. I'm talking about it. Let us understand there is a biological aerosols. When we talk about biology, always remember that anthrax is the one of the biological agents which is being used, have been used by the terrorists in the past. This will be released in order to toxicity concern. If you are saying it, is it okay? Now, there is a comparison chemical warfare agents. There is a comparison between biological warfare agents. This is the milligram level. It's a high concentration, more or like. When biological agents, even single particles, this is again nothing but aerosols. Only thing is the highly khatarnak aerosols. That is a highly toxic and dangerous aerosols. They may have the size of 1 microns, and then we'll be having the non-spherical particles. The reason I'm highlighting these 2 points, these 2 things is going to help me out how I can use LIDAR for detecting these biological aerosols. So I'm trying to link these examples to my technology, how I can use it, how I can detect it. And most of the aerosols, these are the shapes, even microscopically, if you are seeing it, these are shapes. As I said, non-spherical, and do they have amino acids and proteins? So this is the marker. This is a marker, fluorescence markers. I'm going to use this one and this one for my LIDAR technology for detection of these things. Okay, these are the 3 important essential requirements. Let me move on to the, this is the whatever I suggested you. Now the challenge comes the detection. Once if it is released, there comes the importance of the detections. How quickly you are going to respond it and how far you are able to detect. These are the very important standoff sensing, selectivity, and high sensing response time. There are sensors which are available to meeting our requirements. However, they are all in situ instruments. Hence, we go for the LIDARs. And LIDAR advantage, anyway, you are very well aware. If you have the vehicle mounted system, you can take to any of the suspected area and you can do continuously, you can monitor and you can deploy it in the building, top of the buildings, you can monitor it. And you can, by doing this one, you are giving the information for the troops for safe movement in forward directions. Yeah, this is the, just for the continuity sake, Sir has explained very well. This is simple, the concept of radar. You are just firing the laser pulse into the atmosphere. It gets scattered or absorbed. What is coming in 180 degree in the forward direction, you are receiving with the telescopes. Laser source, the physical phenomena, what is happening could be a scattering, absorption, fluorescence, whatever it is. It's all objective, scientific objective, what you are looking for it. Then you have the optical receiver, detectors, controllers, and algorithms. These are all essential part. If you understand this one, then you have to answer this table. Hence, you can build the systems. Now I'm going to talk about how you can build the system. If you want to build the systems, you should be clear about what is your objectives. What do you want to do it? You want to do it aerosol measurements, cloud measurements, or chemical measurements. Accordingly, you are going to define and you are going to finalize the system requirement specification and realization of system hardware and integrate. There are 10 aspects which you have to critically look into that one. After that, you can go for the building the systems. So now, coming to the first one, these are first prototype systems which we have built it. In the most of my system, I have used IR radiations. I have not used 532 nanometer because I have a very good penetrations capability in the daytime. I will show in the bright noon time how I measure even clouds up to 12 kilometers. And I have used only 5 millijoule systems and the telescope is 100 mm. This system is just toy. We can dismantle it, mount it back anytime, and we can do it. And this system has been taken to different locations. Manali, this is sub-zero temperature we have taken. I have done the measurements. In Delhi, high pollution event, we have measured it and we try to see what is the pollution layer height. In Kolkata, we have taken the airport and try to report the cloud base height. And we have given instruction to the pilots. And fourth one is Kochi. It is, again, we have done it at the Indian Naval Base. And again, there is a requirement during monsoon time, we have done the experimentation. We have reported the capability of the system for meeting their requirements. This is the system which we had of 5 millijoule systems. And we put a Vaisala equipment also was there. And we have tried to evaluate. Basic is the concept proof. Are we able to get it? And we are able to, how far we are able to penetrate it? This is a daytime measurements we have done it. This is the result which we got it using our systems. And we could map it very beautifully, the boundary layers. And over and above, there is an occurrence of clouds even between 3.5 to 4 kilometers. This is Vaisala also reported. This proves that yes, that we are able to give at par with the results being reported by the commercial equipments. This is another systems, LES and ceilometers. This is again our system. We put it just next to one at the airport. And the results, they are graphical windows given by LES and company. And they give the information like this, and we are giving it like this. And we have seen that during that duration of operation, we were able to map it and give similar information. And this is another thing which we have the XDG IMD. They have placed the requirement to us, the more number of LIDAR system, hence we have developed it. And this is the one temporal acquisitions, how the clouds evolves and disappears, that we have mapped it. When we try to get the backscatter information, all the multiple layers and the thickness also we can get through our softwares. And we can get the boundary layer height. And we can report cloud different base heights, because this is the information which they don't want to know with respect to time, how the base heights are keep on evolving. So that also we have reported as per the requirement of the Air Force or airport safety aspects. Further, same system we have used for the pollution monitoring. And this is an actual photograph which we have taken during the one event, the highly polluted Delhi things. And we have operated our system. This is our data. This is our data. And we could see that up to 3 kilometers, there is a continuously, we are able to see it. And we have seen it for a week about continuous. And similarly, we try to compare with Vaisala. Yes, that also reported. And further, we have tried validated with Calypso data, and that is also showed. There is a pollution loading. And further, we have tried to evaluate what could be the sources, and we have analyzed it scientifically and found that there is a long range transportation of aerosols from the Central Asia. And this is another same, because now the same system, we have just dismantled it and taken to the another air, this is a naval base. And this is another Vaisala kilometer which they are using it. The problem with this kind of system, they work perfectly only for 6 months. The main issue why we are into this business is the commercial equipments work comfortably only for 6 months. Thereafter it fails and we fail to rectify it. And after sales service support is very high, costlier than these systems. And this is also we have tried to validate it, and we have seen it. Lot of clouds passes over these stations. We have recorded it. Even certain incidents we have seen it as if it is something rain is occurred within the cloud layer itself. Here nothing is clear. There is a cloud, but there is a signal pattern which we could say is that could be rain which is occurring there, but it did not reach. And we can change the system with given any elevation angles and the different vertical angle and the elevation slant angles, we can completely get the informations. Why this is important here is in the ship, helicopters or aircraft can land from any directions. So vertically looking lidar will not serve the purpose. We should have the scanning lidar also. So that will answer. This is the manual, but we can put it the automated system also. That also will come into the coming slides. Further, same system, we have taken to Manali. This is a Manali. The temperature was sub-zero. Even -4 also we recorded it. Even we have recorded during rain also. And we have recorded during snow also, how the signal pattern is seen. But in the firing angle is different, not the vertical. This is one incident. We put it in the vertical configuration. We were able to map the clouds, which is present up to 3 kilometers. In between, there is a rain came, and we started putting the system in the slant ranges. Then we were saying, we were able to see that when the cloud, when it is reaches, what is the height at which it starts raining? That we could see it. When there is a break, then again it's building up. All this information, we were able to map it. Similar way, another incident which we put it in the early morning time, in the again slant range. This is the data recorded for completely snow. When it is this slight snowing was taking place, high bright red means high intensity, backscatter is very high. When it's clear, it's atmosphere is clear. When again rain started, when the snow starts, intensity of backscatter is very high. This information also we tapped it, and in fact in the snow area, people wanted to know whether is it safe to reach hilly terrains, what is the cloud base height, either likely to rain or not, or snow likely to happen. So they want to have kind of small, short scale predictions. And we could see that these are the system, one could be the one of the solution for the short duration aspects. Further, again, because another system is we try to develop the prototype systems. This is one simple scanner that we have used only 2-inch scanning system, only 2-inch lens only we have used it. This system is able to go even up to 2 kilometers. I will tell you how cost effectively we can build a system at the end of that. This is only 2-inch with the filters, and we have tapped up to cloud information, the aerosol up to 3 kilometers. And this is 532 nanometer also we have used for our studies. And the entire software, it is built in-house. Whether put it, what should be the laser controller, receiver controller, what the scanning sequence, every information we can get it. And we do have the depolarizing lidar setups. The depolarizing lidar setup is meant for the non-sphericity of the aerosols, but mostly we use it for the bioaerosols. So then coming to the next concept is the differential absorption lidar. This differential absorption lidar especially is used for the chemical sensing. The main crux is it transmits two wavelength. From the laser source, two wavelength will be transmitted. Each one wavelength is really strongly absorbed, another wavelength weakly absorbed. The difference is these two signals will tell us how much concentration it is present, and the time of flight will come to know what far it is, how far it is, and the wavelength absorption will tell us what it is. So three information we can get it. And the signal processing methodology is going to be like this. Your return signal will be in the online, offline. Online means strong absorptions. Online means strong absorption. Offline means weak absorptions. Whenever there is a cloud or chemical cloud, I mean, they will absorb differentially. Hence the signal differences. And when you process the data, at the end, you will have the concentration informations. This will give us range information. After processing this algorithm, when you implement it, you will have the concentrations. This is the philosophy behind this system. And this one of the important information, IR absorption spectra of important chemical warfare agents. Almost all the chemicals will absorb in the 8 to 12 and 3 to 4 due to vibration and rotational events. These are primary absorption and secondary absorptions. Even this is the region, even almost all the pollutants also absorb it. If you want to do any pollution monitoring, you have to target this band or this band, no other band. If you want to have any pollutant measurement using lidar, these two bands only you have to target. And we have attempted these two targets, two bands for our systems. And methane is one of the commonly available, and we can monitor using this lidar. There is no other lidars. Here also I will tell you how we have done it. Before taking up the main systems, we do develop prototypes, scaled down versions, to have the concept proof and understand the criticality of the subsystems. And this is one of the systems. This is a trolley mounted, and the operating 9.2 to 10.8 microns, and its energy is very less, something around 1 to 2 millijoule only. And it has the range capability 1 to only 100 meters. We simulate, we create some chambers and introduce some chemicals inside, allow the laser radiation to pass through this path, and try to record over the time how do they vary, signal how do they vary, how the concentration disperses. This is what actual scenario is going to take place in the atmosphere. That with the proof I will show you now. This is the full-fledged vehicle mounted lidar system which I have developed in Delhi Elastic, that operates in 9 to 11 micron and 1 micron. I have the aerosol measurements channel also here, but this is for the search operations. And it has a range capability going up to 5 kilometers. The vehicle is a Tata LPTA, and I can move this gimbal 360 degree, elevation minus 10 to 20 degree. This is a schematic diagram which we have used it here. This system we have built on our own with the help of industry. We have, through all the development process, we have involved industry also. Now we have created industry base for the lidar developments. Some 5 industries are there. I will tell in the end of my presentations. These are the once after developing, we take to the remote locations for the test and evaluations. This is a control panel. This is one of the representative picture of the data. Now, when we go for the operate in the 9 to 11 micron, there are 60 wavelengths are there. and 60 wavelength behave differently if they are transmitted to the atmosphere. And it will be like this. They will not be uniform because the atmospheric constituents, atmospheric species absorb these wavelengths. Accordingly, signal will differ, and based on that, we can take the information, what are the wavelength I should use it for the detection of chemicals. And for example, water vapor, something 10 or 20 and 10 or 16, these wavelengths are mentioned here. If I use, I can get the water vapor information in the atmosphere. Even vertical range or slant range, whatever it is, I can get the profiles. And this is one of the information we could see that something around 8,500 ppm concentration we have measured it. Normally the background concentration around that 8,000, 9,000 and 10,000 depending upon the season of the measurements. And this is only 10p20, 10.6 micron when you transmit into the atmosphere. How aerosols behaves, clouds behave, signals. This is the two clouds which we have measured in the atmosphere in the 10.6 micron range. And we have measured the entire wavelength. Now this is another one, ozone measurements. I can use these systems for ozone measurements. And I will be using this 9p14 and 9p24. There are two wavelengths. When it is being transmitted over the atmosphere, again, they will have differential absorptions. Process the data, you will come to know what is the concentration there. That is around some ppb level, we have measured it. And coming to ethylene. See, I'm showing the ppb level of measurements with these systems. So that much accuracy and sensitivity we are having with these systems. And we have measured ethylene. This is around 210 ppb. This is around 160 ppb. This is a normal background concentration in the atmosphere. After evaluating, this is the steps which we follow it for the system performance evaluations. After subjecting all those things, we get into our business. We release some remote locations. It's in the hill area. This is the smoke case. Actually, is the chemical agents. They release it through grenades, allow it to spread, and try to measure what is that concentration, how they dynamically vary. And we have this is a signal which we get it from this canopy, where in which aerosols, that means chemical aerosols were there. And differential signal, real time we can measure it and we can quantify how do they vary. I will come to know what is the target range, what is the concentration, dynamically is varying it. I can tell you what is that, it's present. And this is the algorithm which I told you earlier. This is also we have built it within our laboratory, which can be used directly into the, just upload the data, it will give the all the desired informations. After building the vehicle mounted lidar systems, then I have gone through the absorptions data which I showed you. All the primary absorption 8 to 12 microns. There is a overtone absorption. Almost all the molecules have the absorption in 2 or 3 to 4 micron band. If you can target that also, you can realize the systems, you can develop the systems. Advantage is systems going to be very small. Earlier one is a very big vehicle. It is powered by generator and little bulky. It's like a hathi, it's an elephant. But another system which we developed, this one, doing the same features. But I'm operating 3 micron band. 3 to 3.5 micron, 450 different wavelength I have it. Not one wavelength, 450 different wavelength I have it. I can fire simultaneously in the atmosphere. I can characterize the atmosphere and can detect any chemicals present in the atmosphere. And for example, 2, 3, here I will present it here. The system is going to fire 5 millijoule and 10 watt system. I'm using only 20 centimeters. This telescope again is built in India. We have not bought anywhere. It is built in India only. And this entire control panel we have developed in India. The operator can have a look through the camera where he is looking and where to fire, when to fire. All assistance we are providing to the systems so that he can comfortably sit inside the room and he can operate it. So now again, tripod mount, I can put it in somewhere. If I want to take into the field, I used on a Stallion vehicle. mounted inside the Stalin bank. We have taken to the remote locations because I cannot handle actually the chemical agents, the normal laboratory conditions. Since I have 450 different wavelengths, I try to characterize how the atmosphere behaves, especially aerosols and absorptions. This is the first one is wavelength starting with 3000 to 3450. Just try to measure the signals, what you get back to your system after transmitting the atmosphere. This is a kind of patterns you are going to have it. After getting this data, and we have compared with the model data, that is a SkyCal, it is available in the internet. And we have seen that our information is more or like perfectly correct. Thereafter, we have gone to the why these dips we are getting in the transmission spectrum. Then we have analyzed HITRAN database. Then found that these are the chemicals which predominantly absorb. These the dips are mainly to N2O, O3, and NO2, C2H4, and CH4. After this one, we have targeted methane. Let us try to see that methane, how far we can measure it and how much we can quantify it. That also we have done it. This is one of the example. We have transmitted after identifying the HITRAN database. This is the region which we have seen it. This is the weakly absorbed, strong. This is strongly absorbed. I can say this absorption cross section. Hence, it is online, strong absorption, weak absorptions. Next, we have taken pure methane, allowed the same radiation into the cell, absorption cell, recorded it, and I have seen that 332, here is weak absorptions. Hence, very good returns. Strong absorption, weak signals. We got it. So we have evaluated wavelength selection pair. That is very much important, selection of wavelength pair. Thereafter, again, how the atmosphere is going to behave it. We allowed into the atmosphere and we have seen it consistently. Stronger absorption lines goes down and weaker one is coming up. And even under topographic condition, if there is any building, if it hits, how it is going to be the signal. Then also we have seen that there is a significant differential signals. Then again, we had a doubt. Let us see for our period, do they have any significant variations? Almost they do not show much variation. So that online, offline selection was perfectly correct. And they do not show any untoward variations. And statistically, they are stable within the error bars. Thereafter, we have used these signals and try to compute the concentration. And we have done the measurements daytime, entire morning to till evening, and we noticed that concentration is varying just between 2 to 2.5 ppm, and noon time it is showing low value. And the results and interpretation we are presented in optics and laser technology, and this is the result is similar results we even reported by the IIT Chennai, which we have done the measurement over Delhi. Coming to actual applications, chemical agent detections. Again, the system goes into some remote locations which you cannot see where it is. Chemicals is being released, and we try to see what is the differential signals and try to quantify. Here, almost all the chemical, whatever we use it is actually the simulant of actual chemical warfare agents. And then one of the examples which I'm trying to show is, this is the canopy, because we are using this to contain the canopy vapor for some time. Otherwise, it will totally disappear. Anyway, we are keeping this area is open, hence they can leave. When there is no chemicals, we don't see any differential signals. These are range corrected signals. When there is a chemical, quite obviously we will see the differential signals. And after doing this one, we started monitoring continuously till they completely disappears. This is the one time versus concentration into path length, ppm into meter. This region is nothing is there, so it is fluctuating it because of fluctuation. This is the fluctuation could be due to atmosphere, could be due to system parameters. They go always less than 0. The moment you release some chemicals, they'll start enhancing it. When the concentration decreases, then goes down. After seeing this dip, we released one more chemicals, one more granites, so that we are able to see that is it a consistent phenomenon or something erroneous. Then again we recorded. And then this process continued for about 15 minutes. Then we brought back to the system to the 0. This is how we evaluate the systems, and we give the calibration certificate also for the systems. Now moving on to fluorescence systems. This fluorescence lidar, we use it for the detection of biological aerosols. As I told you, biological aerosols, if you are exposed to even 100 particles, that's it. You will be infected, and death is you cannot avoid. If it is released atmosphere, you should have some technology to detect it far off distances. So to address that one, I raise the questions. Aerosol anyway, always you measure it. Cloud, you always measure it. You should have systems which continuously monitoring, and it has to tell that is there any artificial aerosol is present. Suddenly something is coming up, not the air pollutant. Air pollutant is present. Even today, do measurement today, tomorrow they have to meet it with there. As long as it depends the time, lifetime. Whereas the artificial aerosols, they come and they present for a couple of minutes and then they disappears. And you should be capable of monitoring and detecting that one. And this is, we should be able to detect artificially released aerosol clouds. 1 micron could be one of the best solutions. How I will come to that?
5 minutes more.
Okay, sir. Then another thing is, once if it is detected, we should be able to see whether it's biological nature or not. If it is biological nature, then you should identify what it is. Then you have to target it in this band of 290 to 600 nanometer, right? Then thereafter you have to tell me what is the source of origin and what is the precaution you have to take. This is the problems which is given to us to develop these systems. This is what the system concept. 1 micron lidar lasers. 1 micron laser will be fired. It will continuously monitoring the atmosphere and look for any untoward incidents is taking place or not. The moment it's detected, the first thing is you are able to detect something with the far off, even 10 kilometers you can detect. Then due to daytime fluorescence issues, you can UV channel can have the capability only up to 1 kilometer. This information, if you do information, we are able to give it, is good enough for the services. This is just for the informations. All the biological aerosols will be having, these are the proteins which are present. And the tryptophan is one of the things which categorically present in all the living organisms. If you target this one, you can, your job is done. This is, if you excite this tryptophan with the 266, and you will get a fluorescence 355. Hence, you can say that there is a presence of biological aerosols. And this is a kind of system has been even. Next level is depolarizations. Even there are spores or some other interference. Diesel also will fluoresce in that band. To discriminate that one, you need to have the depolarization channels. Suppose if you have the depolarization channels, signals in the parallel or perpendicular channels, and the depolarization ratio, you'll be getting it like this. And once the comparison rates we are happen to see, all the biological aerosols will be having higher values, interference will be having lower values. The reason is, if the diesel, if they present the vapor form, more like spherical, hence do not have the significant depolarization ratio. Whereas the aerosol, they are the spores, non-spherical, hence they have it. This is the technique which has to be used in the fluorescence lidar. Again, we do calibration systems and validation systems. We develop exclusively for the small system. This is the one biosensor. This is patented also. And we release the aerosols inside, biological aerosols inside. And it is illuminated with LED arrays having the 280 nanometers and 32 channel PMT we have it. And we measure the entire spectrum for all the biological aerosols. After having this one, only we don't believe the literature, validate it here, then take it in our next systems. This is the LIF fluorescence lidar systems, having the range capability 1 kilometer, and we use 266 nanometers. And this is one of the fluorescence signals. We get it from 1 kilometer distance. We release it artificially like this. There is a different containers. We have it with all the safety precautions. Release it, measure the fluorescence. First, detect using 1 micron, detect the presence of aerosols, and fluorescence, measure the fluorescence signals. And third is the depolarization and identify this actually is a bacteria or something else. So this is a step which we follow it, and we have carried out exhaustive trials and experimentations. Now, coming to after evolving this technology, I told you 0.2 micron to 12 micron we are working it for meeting the requirement of society. Now, we have come to the level so where we are now, what we can do the society. Now we have developed some projects, we have taken it, and the order have been given to industry partner. This is the one systems CL10, we call it cloud lidar, 10 kilometer range, and is 20 microjoule systems. High safety aspect is there. This is IP66, that means all weatherproof systems. And I can move azimuth 0 to 360 degree, elevation plus 20 to minus 20. And it will be working minus 25 to 50 degree. And these are the parameters we will be given. This is the initial, this is the testing which we have done in industry. And we could go up to 8 kilometers. And we have this system is next couple of months, it will be ready for delivery for the further evaluation. This is another system. This is again 10 microjoule we are using it. This system daytime is going to give the cloud information, aerosol information up to 10 kilometers. Again, this system, it is not having any scanning options, only vertical mount. You mount it wherever you like. And it's a 2 industries from Hyderabad, they are developing these systems. And 7 equipment we are developing it, it will be deployed in different locations in India and evaluated. Coming to this is the aerosol lidar. So next 2 slides, sir. This is aerosol lidar, which is operating in 1 micron, 0.3 microns. 1 micron, we are going to use it for aerosol measurements. And 355, we are going to use it for Raman measurements. And this is the entire Newtonian configuration we have it. Right now it is under realization. This is a CAD model, is the actual system CAD model which is being developed. This is being developed by one of the L&T Defense from Bangalore. This is under production now. Coming to another system, the dial systems. Again, this is a kind of complex systems, mobile based. I can move it in the 360 degree and different elevations. And there are no other system, I'm seeing it in India, and internationally they have it like this. And this is being developed again in Bangalore, one of the industries is developing it. For this system, our system is the only reference for this. And again, is going to will be used for detection of chemical agents going up to 2 kilometers. And it will have the azimuth elevation scanning as per the specification which I have mentioned it. All those things, they have to meet the mill grade JSS Fanta 5 category. With this, I try to conclude it. My main is whatever R&D which we are trying to do it, which has to lead into something products, which meets the requirement of society, and try to make us self-reliant. Jai Hind and thank you. If you have any queries, please let me know.
Because of shortage of time, we will not take up any question. If you want, they can directly contact you.
Okay? Thank you. Thank you very much.
Can we have his contact information?